This code is simple to create a count plot of the stroke variable in the dataset. To visualize its distribution, it also prints the normalized value counts to show the proportion of each category. The plot title is set as target variable distribution. And this code generates histograms for the numerical features, age, average glucose level, and BMI from the dataset. It uses 20 bins for each histogram and arranges them in a 10 times 5 figure layout to visualize their distribution. And this code creates a heat map to visualize correlations between the numerical features in the dataset DF chain, helping to identify relationships or multilinearity between variables. This code generates kernel density plots (SKDE) to compare the distribution of numerical features between stroke and non-stroke cases in dataset, helping to visualize differences between the two groups. And for this part, this code performs categorical data encoding. It one-hot encodes categorical features like gender, work type, residence type, and the smoking status using BD get dummies, and it converts the ever married column into a binary format. And for this part, this code creates new categorical features by binding numerical values. It categorizes age, BMI, and glucose level into groups, then applies one-hot encoding to these new features for both training and test datasets. For this part, this code applies SMOT, synthetic minority oversampling technique to balance the dataset by oversampling the minority class. It removes the stroke and ID columns, resample the data, checks the new class distribution, converts the resampled data back into a data frame, and displays the first few rows. This code chains a random forest classifier on the resampled dataset and evaluates its performance using a learning curve. It plots training and test accuracy over different training sizes to analyze model performance and detect overfitting or underfitting. And for this part, this code extracts and visualizes feature importance from the chained random forest model, displaying the most influential features in a bar chart to analyze their impact on predictions. And we could see that age plays the most important role in affecting the stroke. This code uses select from model to select important features from a chain random forest model based on a mean importance threshold. It then trains a new random forest classifier using only the selected features. And it's the second model, XGBoost. It trains an XGBoost classifier on the resampled dataset with specified hyperparameters, including max meters equals to 1000, max depth equals to 10, and the learning rate equals to 0.01 to optimize model performance. And this part, it performs hyperparameter tuning for an XBoost classifier using grid search CB, testing different combinations of parameters to find the best model based on accuracy. This code chains light GBM classifier with specified array parameters and evaluates its performance using five-fold cross-validation, uh, printing the accuracy scores, mean score, and standard deviation. And we found that the light GBM has the best performance.